In this video, we'll write a simple C++ program using loops, arrays, basic data types, and output, and we'll see how to find something that you need from standard libraries. We'll jump into Visual Studio, where I have created a new solution, an empty solution. It contains just one project, which is an empty C++ project, and to that so far I have only added one file and wrote the main function. The main function is the entry point to all standard C++ programs. In the assignments you will mostly not see the actual main function because it's hidden in the NVIDIA framework. But this is a valid C++ program, and we can run it to see what happens. We can choose Start Without Debugging, and even though we have not built this, the Visual Studio will notice and it will build it for us and then run. Nothing is happening, but our program is running. So those of you coming from a Java or C# background might notice something is missing. There is no class. This is just a standalone function, and we don't have to have any kind of object orientation in here. If we want to print something, we can do it like this. And this is not quite good enough. Visual Studio is showing us some red squigglies and saying that it doesn't know what this name is. stdcout is what we use for printing into console, but to use it we have to include the library where it is in the standard C++ libraries. And it is found in the IOStream library. Now we can run again, and we managed to print the course code. So how did we know to look for this stdcout in IOStream? Assuming that we already know what we're going to use, cout, we can go to cppreference.com. This is a site I recommend for looking up things in the standard library. It's not an official one, but it might as well be. And you can browse for what you need. If you needed a data structure, you would probably look in the containers library and the options available there. But now we know that we want stdcout. So let's search for it. And there it is. Once we have successfully looked it up, we can see that cout is found in the header IOStream. So this is what we have to put in our include statement. And notice that cout is of type std ostream, short for outstream or output stream. And C++ uses data structures called streams for doing I/O. Here we use it for console output, but streams are also used for reading and writing files, some string handling operations, and so on. And the way the streams are used is that you can push individual pieces of data into an output stream, like cout. You can read individual pieces of data from an input stream, or you can pipe streams into one another. Going back into the code, Now we'll take a look at what's actually happening. So we are using the double angle bracket operator. This is the operator that is used to push something into an output stream, and then we just repeat that for various kinds of data, and the operator is defined for all of these. And to be exact, what's going on here, why we can write all of this in a row, is that first the operator runs for one piece of data, like so, and the return value of this operator is the same stream. So after this piece of string has been pushed into the stream, the value of everything inside the parentheses here is std_cout, and then the next piece of data gets pushed in, and so on and so forth. I'll remove the parentheses, and in a similar fashion, if we wanted to do some input, we would use an input stream, and we would use the other operator. So I'll introduce an integer variable called I, and I will read a number into it, and I'll use the cin stream. And then for good measure, I'll print out what we managed to read from the input. And we'll try this. So now the program hasn't ended, it's expecting our input. So we'll give it some input, and we see that we managed to successfully read that. So it's kind of logical. You have an operator going this way if you are pushing stuff into an output stream, and you have an operator going this way if you are reading something out of an input stream. Next, we'll look at arrays. We have a choice of multiple types of arrays in C++. One is the old C-style arrays. They look like this. So we have the data type inside the array, then the name, and then brackets. We can immediately initialize this to some values, like so. It's not possible to change the length of the array afterwards, so this has a length of 4, and I'll put in a loop to print what we have. And we still have our input going on here, so I'll disable that to speed up testing the rest of the stuff. So now we will no longer be reading the input. Commenting code happens exactly like it does in Java or C#. We can comment individual rows with double slashes, or we can comment a larger space with a slash and an asterisk, and everything in between will be commented out. So what happens if I try to misuse this array? So 3 is the last valid index. What happens if I try to access, let's say, 1000, which is definitely not to be found in this array. Our program crashed, and we have very little indication why. We'll close it down and take this out. So C++ allows very low-level access to things, and in this case we just tried to mess with memory addresses that we shouldn't have, and the compiler and the debugging system here do not have exact info of what we tried to do. We shouldn't be using the old style array. It doesn't have much functionality and it's not safe. In worst case, we would not even get a crash. Our program would just work in some undesired way, but subtly enough that we wouldn't even notice. So what we actually want to use in C++ is generally vector. And vector is a dynamic array, so it works like an array as long as you don't change its size, but you have the option to grow it or to contract it. We have to include the vector header, and then we'll make a vector. So it's std vector, and part of the name of an individual vector type is the data type inside the vector. So this will be a vector containing integers. I'll call it vec, and I can initialize it in exactly the same way as I did the array. And I will borrow our printing code here to also print the contents of our vector. Now we should get two sets of the same printout, which we do. And then we'll try to abuse our vector the same way we did the array. And we'll try to read the 10,000th index in the vector. This should not work. And it doesn't, but this time we get a much more useful error message. So we triggered an assertion and we get the message vector subscript out of range. So now we know exactly what happened and on which line of the code. Regarding vectors, there are generally two ways we want to create them. The first way is that we create an empty vector. And then one by one add our data to the end. We can do that with the pushback method. So pushback grows the size of the vector by 1 and then places this item of data to the new spot at the end. And I'm going to push these 4 values in. And then again print the whole thing. And it works. The other usual way we use the vectors is that we initialize the vector to a size that we want it to be in the end, and then assign into individual indices. So we would do that like so. We will give this a constructor argument, and we'll tell it to reserve space for exactly 4 integers. Now that it's done, we can assign directly into the indices. All of the contents are now default initialized, so the integers inside will be zeros. So now we are allowed to do this. With the previous vector, since we created it to be empty before we do the pushbacks, there's nothing inside, so trying to access any index will produce an error. And we'll verify that our newest vector also works. We have only manually placed 2 values in there, so we expect that there will be 2 more values that are both 0, which is the default value for integers. And here we are. We get 11, 12, 0, 0. Now some of you might be worried about the pushback approach, since we are growing the vector with each pushback. You might wonder, is this expensive? Does it cost performance? And the answer is not much. So this is quite efficient. You should write your code in the way that is clearest to you, and you don't have to reserve space ahead of time just for performance. But the second way will be a bit faster. Besides vector, there is also an array in the standard library, so that is also a C++ data structure, and we'll briefly look at that also. And we have to include the array header, and then we can make an array. So arrays are fixed size, and here again, as part of the type name, we have to tell the data type inside the array. It will be an integer, but then also we will have to tell what size this array type is. So I will create an array of size 3 exactly. I will call it A, and I will assign 3 to 1 as the contents. Now the size of A can never change. You can rewrite the values inside, but you can't grow it. So this is something you might want to use instead of vector if you want to make clear that this array can never be any other size than 3. With all of these vectors and arrays, we can make copies just exactly like we would copy an int or some other basic value. So if I make another of these, an array called B, I can just copy A into it like so, and this will still compile just fine. We are not printing any of this newer stuff. But you might expect that std array int 3 and let's say std array int 5 are somehow related. So this is an array of length 5 containing integers. We can create one of these, but if we try to assign one of these smaller arrays in there, we get the squigglies again. So there is no conversion, even though these are both based on std array. They are totally different types, and in an object-oriented sense, std array int3 and std array int5 are not related at all. So if you want to copy data from one to another, you have to do it in some other way. And likewise, std vector, let's say std vector int is not actually related to std vector float, even though you can assign integer numbers into floating point variables and vice versa. You can't assign from an std vector float into std vector int. And later we will see how we can easily copy stuff between these, but it does not work as easily as here, where we actually have two array int3s. And I will comment out this stuff that doesn't work. In the next video we will talk about namespaces, and we will get rid of this std prefix that is everywhere in our code right now. So for now, just remember that the std stands for the standard library. This is how you know that the object comes from there. So until next time.